the dawn of engineered evolution. For over 500 million years, life on Earth has evolved through natural selection, mutations, and environmental pressures. But what if evolution was no longer a slow, chaotic process? What if humans could take control of the blueprint of life itself? Could we create entirely new species? Would genetic engineering allow us to design life to survive extreme environments, including other planets? Could we accelerate evolution beyond recognition? This is not speculation. It is happening now. Scientists are already using advanced genetic modification techniques to alter life in ways that were once unimaginable. From CRISPR gene editing to synthetic biology, we are on the verge of a bioengineering revolution. But where does this path lead? What kinds of creatures will emerge in the coming decades? The science of evolutionary engineering. Natural selection takes millennia to shape a species. But today, genetic engineering allows us to rewrite DNA like software, cutting evolution's timeline from millions of years to just a few months. CRISPR-Cas9, the revolutionary gene editing tool, enables scientists to precisely alter the genetic code of organisms. Already, we've seen virus-resistant pigs, glow-in-the-dark rabbits, and supermuscular dogs. But this is just the beginning. The next frontier isn't merely modifying existing creatures. It's creating entirely new life forms from scratch. In cutting-edge labs, researchers are using synthetic biology to design life at the molecular level. They are assembling artificial genetic sequences, creating organisms that have never existed in nature. Xenobots, microscopic living robots made from frog cells, can move, heal themselves, and even work together. Could the future bring self-repairing animals, bioengineered drones, or creatures that modify their own DNA? The rules of evolution are no longer fixed. We are rewriting them. The future of predators and prey. Once natural selection is in human hands, predators could become more efficient than ever before. Imagine apex hunters designed to be silent, invisible to infrared detection, and capable of sensing electrical fields like sharks. A genetically enhanced wolf could communicate through pheromone signals, hunting in packs with unmatched coordination. At the same time, prey animals would evolve new defenses. Some species could be engineered to release paralytic toxins when attacked or develop bone structures as hard as reinforced metal. Others might be given bioluminescent camouflage, allowing them to blend into the night. Even plants could be redesigned to fight back. Picture trees that secrete neurotoxins against herbivores or crops that alter their chemical makeup to deter pests. Evolution is no longer a game of chance. It's a war of design. Artificial intelligence and evolution, as powerful as genetic engineering is, it pales in comparison to what happens when artificial intelligence enters the equation. AI-driven bioengineering could analyze billions of genetic possibilities in seconds, designing creatures optimized for survival in any environment. A self-improving organism could analyze its surroundings, rewrite its DNA, and evolve on demand. The process of evolution, which once took millions of years, could occur within a single generation. Could we engineer intelligent species that surpass human-level cognition? Hybrid biocybernetic organisms could blur the lines between technology and life. What happens when living organisms are programmed like computers? Could AI create life forms that are half biological, half machine, capable of surviving in deep space? Terraforming and bioengineered ecosystems. On Mars and other planets, scientists are experimenting with genetically modified bacteria designed to create breathable air and fertile soil. If successful, terraforming entire worlds using engineered ecosystems could become reality. Imagine forests engineered to glow in the dark, replacing artificial streetlights. Picture plants designed to capture carbon emissions and clean the atmosphere at an unprecedented rate. Cities might be powered by self-sustaining biological generators, organisms that produce energy as efficiently as a rainforest. The ethical dilemma of engineered evolution. With great power comes even greater responsibility. Should we create new species just because we can? What if genetically modified creatures outcompete natural life? What happens when human DNA is engineered for intelligence, strength, and longevity? Do we risk dividing society into the genetically enhanced and the natural born? We are no longer observers of evolution. We are now its architects. But are we prepared for the consequences? The future of human evolution. Forget survival of the fittest. We are entering the age of survival of the smartest. Scientists are already working on genetic modifications that could enhance human intelligence, increase memory, and even slow aging. Could the next generation of humans be designed for enhanced strength, intelligence, or resistance to disease? What happens when aging is eliminated and humans can theoretically live for centuries? Would civilization collapse under the weight of an immortal population? With AI-driven gene editing, could human evolution enter a self-directed loop, with each generation more advanced than the last? Hybrid species and crossbreeding. In laboratories today, scientists are fusing the cells of different species, creating chimeras, organisms that contain genetic material from multiple animals. Human pig and human monkey hybrids have already been developed for medical research. What happens when this research is no longer limited to medicine? Could we create hybrid creatures with human-like intelligence? What ethical boundaries would we cross? Some scientists suggest that interspecies genetic fusion could combine the best traits of multiple animals, creating creatures that could never exist naturally. Could we design intelligent, ultra-adaptable beings for deep space exploration? The birth of synthetic alien life. If we can engineer life to survive on Earth, why stop there? If life exists elsewhere in the universe, it may not be based on carbon and water like Earth life. Could we create silicon-based organisms to survive on high-temperature planets? Could bioengineers design organisms capable of thriving in Jupiter's atmosphere, absorbing energy from electromagnetic storms? If alien life doesn't exist yet, we may not need to find it, we may create it ourselves. The first post-biological organisms. Some scientists believe the final step of evolution isn't organic life, it's artificial life. Could we engineer a species that doesn't need food or water, but instead thrives on pure energy? What if we built self-replicating biological machines capable of surviving in deep space? When life becomes more machine than biological, is it still life at all? Beyond evolution, the story of life on Earth has always been one of change. But for the first time, change is happening by design, not by chance. Evolution is no longer about random mutations, it's about engineering perfection. Should we embrace this future or fear it? Speech balloon your thoughts? Should humans control evolution? Should we create new species? Loudspeaker leave a comment. Bell subscribe and turn on notifications.